So, the James Webb Space Telescope, JWST, is going to be able to look at planets we've discovered around distant stars. In the vast puzzle of our universe, this telescope is finding pieces we didn't even know existed, shaking up everything we thought we knew. Could our laws of physics be in for a rethink? Is our universe textbook due for an update? Renowned physicist Brian Cox is stepping up to share his thoughts on these earth-shaking revelations. Join us as we are about to journey through the astonishing wonders of the cosmos like never before. Stay tuned and prepare for a cosmic voyage of discovery. Are you ready for a cosmic story? Picture it, Christmas Day, 2021. While most of us were unwrapping gifts and sipping hot chocolate, the world of astronomy was getting the biggest present of all, the launch of the James Webb Space Telescope, or JWST for short. And let us tell you, this isn't your run-of-the-mill telescope. It's the biggest, baddest optical telescope we've ever put in space, packing a colossal primary mirror that's 6.5 meters across. Now, the JWST isn't just hanging out up there for the view, its mission is to cast its superpowered gaze back in time, studying the first galaxies that appeared in our universe. It's like a cosmic detective unraveling mysteries about the birth of stars and planets. How does it do all that? Well, it's equipped with 4 scientific instruments: the near-infrared camera, NIRCam, the near-infrared spectrograph, NIRSpec, the mid-infrared instrument, MIRI, and the fine guidance sensor, near-infrared imager, and slitless spectrograph, FGS, NIRIS. These are the tools it uses to peer into the atmospheres of distant exoplanets. And here's something that'll blow your mind: the JWST is so far out in space, orbiting around the Sun, that it's about 930,000 miles away from Earth. At that distance, things get chilly, minus 223 degrees Celsius chilly. This impressive mission isn't a solo act. It's the result of an epic collaboration between NASA, the European Space Agency, and the Canadian Space Agency. So next time you look up at the night sky, remember that the JWST is out there, unveiling the mysteries of our cosmos. Isn't that something? You know how we're always wondering if we're alone in the universe? Well, we've been doing more than just wondering. We've been peeking into the celestial depths with telescopes, uncovering secrets hidden light years away. Let's take a journey through the cosmos, shall we? Our destination, TRAPPIST-1b, an exoplanet that's been a real game-changer in our cosmic understanding. So, what's TRAPPIST-1b? It's a super-Earth exoplanet, which is essentially an astronomy way of saying it's kind of like Earth, but, well, super. It's not Superman or anything, but it is larger than our home planet. In fact, it's about 1.37 times the mass of Earth and 1.12 times the radius. Despite its size, it's still smaller than Uranus and Neptune, the ice giants in our solar system. TRAPPIST-1b is part of a family of 7 rocky planets, all orbiting a unique star called TRAPPIST-1, located in the constellation Aquarius, about 40 light-years away. That's pretty far by our standards, but in cosmic terms, it's almost like being neighbors. The planet was discovered by a team of astronomers using the Transiting Planets and Planetesimal Small Telescope, TRAPPIST, based in Chile, in 2016, with help from other ground and space-based telescopes. One interesting aspect of TRAPPIST-1b is how close it orbits its star, just 0.0115 astronomical units away, about 30 times closer than Mercury is to the Sun. Because of this, it whips around its star in just 1.5 days, meaning it's tidally locked. This means one side of the planet always faces the star while the other side remains in perpetual darkness. The close orbit means the planet receives about 4 times as much radiation as Earth, making its surface a scorching 227 degrees Celsius, 440 degrees Fahrenheit. The James Webb Space Telescope played a crucial role in determining TRAPPIST-1b's temperature. Using its powerful infrared instruments, the JWST was able to measure the planet's heat emissions for the first time. The data also suggested that TRAPPIST-1b lacks a significant atmosphere, possibly because it was stripped away by its star's intense radiation or never developed one in the first place. The discovery of TRAPPIST-1b, along with its 6 sibling planets, was revolutionary in the field of exoplanet research. It showed that rocky planets could form around low-mass stars, the most common type in our galaxy. This opened up new possibilities for studying planetary systems and searching for life beyond Earth. But that's not the only insane discovery. Some findings are making us question everything we thought we knew. 2 galaxies, known as GLASS Z12 and GLASS Z10, have been causing quite a stir in cosmology. These galaxies, discovered by the JWST in 2022, date back to just 350 and 450 million years after the Big Bang, making them among the most distant and luminous galaxies ever observed. The JWST found these galaxies using gravitational lensing, a technique where the gravity of massive galaxy clusters acts like a magnifying glass, bending and amplifying the light from distant objects. In this case, the cluster Abell 2744, also known as Pandora's cluster, helped magnify the light from GLASS Z12 and GLASS Z10. The light from these galaxies had been stretched by the expanding universe into the infrared spectrum, allowing JWST to detect them. These galaxies are mind-blowing not just because of their age but also because of their brightness and mass. They are about 100 billion times as luminous as the Sun, and their stellar masses are roughly 1 billion times that of our star, despite being so compact. This suggests they formed stars incredibly quickly, challenging existing theories about how galaxies formed and evolved in the early universe. Their discovery has led astronomers to reconsider the hierarchical structure formation model, which posits that small structures merge to form larger ones over time. Instead, these small galaxies seem to have formed massive amounts of stars rapidly, hinting at unknown processes in the early universe. Additionally, their brightness suggests they could have played a significant role in cosmic reionization, the period when the first stars and galaxies ionized the neutral hydrogen in the universe. These discoveries imply that reionization may have occurred earlier or been more complex than previously thought. However, these findings are also raising questions about our standard cosmological model. A 2022 paper by Nida et al. Suggested that these galaxies might require new physics or revisions to our existing theories. The luminosities and star formation rates of GLASS Z12 and GLASS Z10 are so high that they challenge what we thought possible for galaxies at such early times in the universe. In conclusion, the JWST is transforming our understanding of the universe, from revealing new exoplanets like TRAPPIST-1b to uncovering ancient galaxies like GLASS Z12 and GLASS Z10. These discoveries are shaking the foundations of cosmology and pushing the boundaries of what we know about the cosmos. The mysteries it unveils may lead to groundbreaking new theories about the formation and evolution of galaxies, planets, and potentially life itself.